So welcome to In Conversation, and the topic we are going to be talking about today is embedded to empowered, and we'll talk about the rise of software-defined products. And I have with me today Prashant Rao, Head of Application Engineering from MathWorks, a company that is a leader in modeling software. And we are going to be discussing some of the key points around the rise of the software-defined products. And if I just kind of give a background on how we have moved, from what products used to be, where everything was hard-coded and when products were shipped to the customers, they would behave in a particular way. But over the years, it has changed into more software-defined features. What customers get in the end can be customized, can be changed along the way, depending on what brings value to them. And it has been a beneficial thing both for the customers as well as for the suppliers of the products. So Prashant, maybe I'll start by asking you, what has led to, first of all, do you agree with this thing that there has been you see a trend more towards software-defined products, and what has led to this rise of this trend?
Absolutely. Thanks a lot, Sanjeev, for this wonderful opportunity. And that was a great layup into the question, I think. And yes, absolutely, I agree. And some of the factors that have gone into this, if we go back a bit, one is technology. So essentially, the accessibility of compute power, the amount of data that you have available, and then one talks about, let's say, variety, velocity, et cetera, of that data. And the third is actually things like the communication, interconnectivity of devices or of processors. So that's lays a foundation for enabling then software, because you got the compute, you got the data, you got the communications. And now then the next part of the technology is essentially the algorithms and the ability to be able to harness the power of those processors and of this data, et cetera. So knowledge in algorithms and in AI, which has developed over the past few decades to what it is today, where we have algorithms that can actually then control your vehicle or autonomously drive your vehicle. So value being driven through algorithms. So that's one aspect of this that we're seeing. So essentially the availability of that technology in both hardware and algorithms. The second part is probably coming from the demand from the consumers or from customers to be able to essentially customize their product in the way that they would like. And that's where software is making that difference. It's being able to, you can customize your product in the manner that you would like it to be for your specific use cases, right? And then it's also the complexity of the environments in which now more and more software is required to be able to control these kind of complex systems. And where legacy systems, mechanical, hydraulic, et cetera, were fine in the past, now they're becoming increasingly smart. Right? Where again, software is that smartness that is going into this. And then finally, I would say also cost plays a difference.
Right.
You would like your hardware that you bought to be able to actually adapt to changes in the future and be as useful in the future as it is today. So you're adding on features as you go along. The value of that hardware is actually sometimes increasing.
Right.
So it's value driven. Software is actually increasing the value of your device over time. And think of that, let's say, from your mobile phone to over-the-air updates for your vehicle, but also maybe over-the-air updates to your asset, to your plant, whether it's a wind turbine or a jet engine or whatever it is. So we're seeing this across the base, and I think these are some of the factors I think would be contributing towards this rise of software in practically all engineered systems.
Right. So if we were to think about some consumer examples which people use from day-to-day life, one thing that comes to mind is Tesla. Would that fall in that category?
That falls absolutely in that category.
Because I sat in Tesla and the car drives itself, right?
Yes, yeah.
So what more could be more software controlled than that car?
Yeah.
Give us one or two other examples, like would robotic
Vacuum
cleaner in the house fall in that category? I mean, just
absolutely.
just to get
a few things. I mean, there is, of course, that from a consumer market perspective. So let's say Tesla, a robotic vacuum cleaner that you can probably update or upgrade as you go along. But also let's take something like, let's say like a truck, where you would like the capability to actually increase the torque of that vehicle at given times.
Right.
As a fleet manager, you may not want your drivers to have that accessibility all the time because it's energy inefficient. But when they need it, let's say to climb a hill with a high load, that's when you can enable that software functionality that will give them that extra torque, for example.
Right.
But in other cases also, like let's say medical devices, low-cost implementations of, let's say, deep learning algorithms for things like, let's say, glaucoma detection. That is some things that can be enabled today, and that they can also increasingly be updated as they go along. So once you get more data, you can actually then upgrade and update your algorithms on these devices.
Good point. So does it also allow us to, the cost of error is much less here also in terms of like how do you fix it also? I mean, earlier if you design something wrong and the whole thing will have to be recalled or the cost of change would be very high. Would that be a factor?
That comes down to kind of the engineering principles, right? So how do you manage your engineering cycle on this, right? And I would say yes, in a way, but also that it is also it's a double-edged sword, right? It cuts both ways. You are now, let's say if you have your devices, you have your cars all out in the market, and then your software that you have pushed out as an OTA, as an over-the-air update, has a single bug, and suddenly all these vehicles are affected by that right away.
Right.
That becomes then a problem. So that is, I think, one of the things that organizations or R&D teams have to grapple with.
True. When it's easy to change things by mistake, if you do update a wrong thing, then likely you are affecting millions of users. Right. So now that brings a role of engineers and developers in the organization, or how earlier organization was staffed and the skills needed. How has that evolved over the years? How do you see the role of that happening in the organizations?
I think that's a very good question, and we see that as we go along with all our customers when we're working with them. Probably, again, going back a bit, in India, for example, we're essentially a services-driven country developing software for the world. But now we're coming full cycle, where that software is actually now running together with hardware, with mechanical systems, et cetera. And that's where the importance of understanding the domain, so domain knowledge, comes back into the picture. And that is where software development and, let's say, mechanical or hydraulics, core engineering development need to go hand in hand.
Got it.
And that's where then engineers working on these kinds of systems need to be able to understand each other, need to be able to collaborate, also then be able to communicate with each other in a manner that somebody from not your specific domain can understand, take your work, and build upon that. I think those are some of the changes that we've been seeing in the past 10, 15 years, and it's increasingly becoming acute, right? Being able to collaborate cross-functionally across domains to be able to build your product and get it out in time.